Okay, hi everybody, I'm Miss Kreppel and I'm here today to talk to you guys about horizontal motion. So horizontal motion is things that happen basically in a straight line. So if you know anything about me at all, you know that I like to swim. So we can do problems that basically about swimming in the pool because we are going to be swimming in like a straight line, or driving your car, or running the 100-yard dash, or something like that. So then what you need to know about these problems is that we are going to be using the trusty old formula, distance equals rate times time. So D stands for distance, R stands for rate, and T stands for time. Now, what you have to know about rate and time is that the rate, feet, if you're doing something in like feet per second, then your time needs to be measured in seconds so that these two units will cancel each other out. If you're doing miles per hour, then your time would have to be measured in hours so that the hours would cancel out. So make sure that whatever rate you're measured in, that your time is going to be measured in the same thing. And what we're going to be doing is basically comparing two things together to see who's going to be winning races. So people are going to get head starts, or people are going to take a little longer to start a race, or something like that, so that we can compare things so we're not just doing really easy ones. So over here, look at this. Hey, a problem appears on the board. So Alex wants to race me, I'm Miss Kreppel, and he swims at 1.3 yards per second. So that is a rate. And I swim at 1.8 yards per second, which is another rate. So if my speed is being measured in yards per second, then I have to also measure my time in seconds, because that's the only way it's going to make sense. And then obviously, like, if my rate is so much faster, I would win the race. So I have to give him some sort of incentive so that he will race me. So I decided to give him an 8-second head start. So that is going to have some sort of effect on the time. So basically what's going to happen is I'm always going to be 8 seconds behind him. And then I'm going to be catching him, though, because my rate's going to be so much faster. Hopefully I'll have enough time to overtake him. So who wins the 100-yard race, and by how much time and distance? So 100 yards is a distance, so that is the length of the race. So distance is 100 yards. Here's our two rates, and then we're going to talk about the 8-second time differential for him. So let's first start with what Alex is going to be doing. So let's see. How long will it take Alex to do the race? So distance is equal to rate times time. So the distance is 100 yards. His rate is 1.3 yards per second. And then we're going to solve that for time. So that's just an easy divide by 1.3, divide by 1.3. So his time, let's see, here's my calculator all the way over here. Hey, hi guys. Okay, so 100 divided by 1.3 is 76.92 seconds. 76.92 seconds. Which means that it takes him almost a minute and 17 seconds to do 100 yards. So it's pretty good. Let's see if I can do better than that. So the problem with me, I'm going to be doing the same thing, except that I am 8 seconds behind. So 100 is equal to my rate, which is 1.8, but my time is 8 seconds behind. So I'm always going to be 8 seconds behind. So with that, let's see what happens. Oh, man. I hope I can go faster than a 1/16. Okay, so I'm going to divide both of these by 1.8. So 100 divided by 1.8 is 55.56. So that's how long it would take me seconds to complete the race, except that I have to have this penalty of 8 seconds. So after he starts, and then I get the start. So basically I have to add 8 seconds to my time. So even with that, plus 8, it takes me 63.56 seconds to finish the race after he starts. So look at that, I win. Yay! Okay, so now the question is not just like who wins, because obviously I do, but the question is who wins and by how much. So by how much, we want to know how much time and then how much distance did he still have to finish in order to complete the race. So the time I win by is all I have to do is just subtract. So it takes him 76.92 seconds minus 63.56 seconds. So I'll just subtract. So 76.92 minus 63.56. So I win by 13.36 seconds. So he's still swimming for that much more time. And so to figure out the distance that he still has to complete is now this is a time, and then we know that his rate, so distance, remember, is equal to rate times time. So the distance that he still has to complete is I take his rate, which is 1.3, times the time that he still has to swim, 13.36, times 1.3. So he still has 17.368 yards to complete, which is like maybe half of a lap. Well, I really crushed him. Okay, so basically we're just using distance equals rate times time. So we compare how long it takes each person to swim the race, and then I win by 13.36 seconds, and then we go back and plug that into our equation to see how much distance he still has to cover in that amount of time. So, you know, I'm really interested in swimming problems. And then let's take it next door to Miss McLean and see what kind of things she's really interested in over there. Wow, I wonder what she's going to be talking about. This is going to be really fun. What kind of things is Miss McLean interested in? Oh, look at, there's Mr. Bennett and Miss Crook. They're probably talking about calculus problems over there. Nerd alert! Nerd alert! Oh, look, here she is. Hi, Miss McLean.
In my classroom.
All right, so I did a problem about swimming because that's what I'm interested in. I wonder what kind of problem you're going to do.
Am I in the shot?
Let's make sure. Oh my gosh, what's that? Your cat.
All right.
Get it? Cat?
All right, so I'm going to do another example for you guys if you want to jot this down in your notes. A little bit different than Miss Kruppel's example. And yeah, it's about my cat, which we got a picture right here. She's kind of has crazy eyes. So Ms. McLean and Miss Kruppel are racing to capture Ms. McLean's cat. Her name is Emma, if you didn't know that. They're each 100 feet away on either side of her. So I kind of started my diagram. Here's me on the left and Miss Kruppel on the right, my cat in the middle. I'm going to go ahead and move my phone now and draw that on here. Let's go ahead and label those distances. So 100 feet is how far each teacher is from my cat, Emma. So hopefully Ms. Kruppel told you that distance is rate times time. That's what we're going to use here to write equations. So let's say that I'm running at a speed of 5 feet per second. So we can just write that on here, 5 feet per second. And let's say Ms. Kruppel's a little bit faster. She's 7 feet per second. But let's make this a little bit more challenging, and let's say that she maybe trips when we start racing, and so she starts a second late. So 1 second late. So yeah, she's going faster, but I don't know if she's going to get to my cat first, so let's find out. So we need to write some parametric equations for me and Ms. Kruppel. So let's start with me first, so Ms. McLean. This is horizontal motion, so all of it is going in the x direction. So we're going to have our parametric equations x equal and y equal, but the y equation should just be equal to a number. We might want to choose just 0 since I'm on the ground, so a height of 0 above the ground. And then my x equation will be what changes here. Ms. Kreppel, similar thing. So x and y, but her y equation will just be a number. Let's just use 0 for the ground. So something we need to decide though before we write these equations is where is the y-axis? So the x-axis is kind of like the ground. Where are we going to place the y-axis? There's kind of 3 logical places. You could put it on me, my cat, or Ms. Kreppel. I think a lot of people choose to put it in the middle, where the cat is in this case, but it could be at any of those places. So draw it on your diagram, and then remember that's where the y-axis is. So the cat here is like 0, 0, the origin. Okay, so for Ms. McLean, for myself, my x equation, since distance is rate times time, is going to be 5t, because my speed is 5, times time, the third variable in parametric equations. But then we need to think about, I'm not starting at the origin. I'm starting left 100 feet. So on a graph, that's actually at negative 100 since it's on the left. So I need to put minus 100 in the x equation then. Again, that's because I'm starting at negative 100, left 100 of the y-axis. Okay. Ms. Kreppel's equation is a little bit different. For starters, she's running to the left, so her speed is actually negative because it's going to the left. So negative 7t. We have to remember she started a second late, so I'm going to actually put some parentheses in here and put minus 1 because she loses a second by starting a second late. Okay? And then she's starting right of the y-axis, so that's going to be plus 100. And she's running left from there. Okay, I'll give you guys a minute to get those equations down. Okay, so let's use these to figure out who wins this race. Who gets to Emma, my awesome cat, first. So who gets to Emma first? Okay. So Emma's at the origin where x is 0. So what we can do to solve this is plug in 0 for x. If we had placed the y-axis somewhere different other than the cat, where the cat is, then her location would be something different. But since we placed it there, her x value is 0. So I'm going to plug in 0 for x in each equation and then solve for the time. By doing that, we can see which one has the smaller time, which one got there first. So if I get t by itself in this first equation, I would add 100 and then divide by 5. So I'm getting 20 seconds. So that's the time that I, Ms. McLean, get to Emma. Now let's solve this one. So I'm going to subtract 100. Divide by negative 7. So 100 divided by 7, or negative 100 divided by negative 7. And then I need to add 1 still to get t by itself. That's that second late that Ms. Kreppel started. So I'm getting 15.28 though. So even though she started a second late because she was running faster, she got there in less time than me. So Ms. Kreppel is the winner. She gets to my awesome cat Emma first. Okay. So one more follow-up question to this then. If she gets there first, what we want to know is how far away was I, Ms. McLean, when she got to my cat? So how far away is Ms. McLean when Ms. Kreppel gets to Emma. Okay. Well, we know it takes 15.28 seconds for Miss Kreppel to get to Emma. So what we could do then is take this time and plug it into my equation to see where I am at that time. Okay? So 15.28 is the time Miss Kreppel gets there. So we're going to put that into my equation. X equal 5 times t minus 100. So let's see, at this time, 5 times 15.28 minus 100 is negative 23.6. Should make sense that it's negative because remember I was starting here on the left, so I'm running this way, so I'm still 23.6 feet shy of getting to Emma at the time that Miss Kreppel made it all the way. So it's only a negative because I'm on the left. So we'll just say 23.6 feet away. So sad times, my cat gets stolen by Miss Kreppel. End of story. All right, so hopefully these examples were helpful. Go ahead and do some practice. Then if you have questions, you can always ask me or Miss Kreppel when we're back.